Welcome back, everybody. Today we're going to talk about polar coordinates. Normally, we use x and y inputs for the coordinate system. So we say this is x-axis, that's the y-axis, and if you want to show a point, show it through the corresponding x value and the corresponding y value. This is right, this is x and y. We can create the same point throughout angle and radius. So what do I mean by that is if you look at this point, that point has a distance from the origin and creates an angle with the origin, with the x-axis. The angle called theta, and here distance is called r. So another way to show a point would be starting with the x-axis, the angle of rotation. So if we're rotating counterclockwise, this angle we call it theta, and the distance from that point to the origin, we can show it as an r. So by picking that the radius and angle theta, we can determine this point uniquely. And this is basically the polar coordinate system. It's going to represent the same x and y value point in a polar coordinate system. So this is x. So okay, so how do we look at the points? Normally, if you have, let's say, if I have a point here, what do I care about is, let's say, if we have this point, the angle that this point creates with the x-axis is basically 0. So the length here would be r. So I can show this point as, say, the length r and angle 0. The 0 would be corresponding angle. So we write this the same coordinate tuple, but we represent it as this one as the radius, or the distance from the origin, and here would be the angle. And angles are written in the radian, and nothing is in degree. There are some ideas about how to show, you can show a point in multiple ways. For example, if you have let's say this is the x-axis, and you have origin here, here's some angle theta, and radius r. So this point, this blue point, would be determined by the angle theta and r. What if instead of theta we consider the angle theta plus 2 pi, meaning going around once, then you have theta plus 2 pi. I can show the same point as r theta as well as rn theta plus 2 pi, because the corresponding angle is still it represents the same value in terms of angle corresponding to the x-axis. So these two, theta plus 2 pi and theta, they're not exactly the same angles. The initial and terminal states, initial being x-axis and terminal state being this line, they're basically the same. So I can say these two coordinates represent the same point. So which means that if I have an angle r and theta, then r and theta plus 2 pi would be the same point, and then r here, comma, and theta plus any combination of 2 pi. And it could be 4 pi rotation, or it could be negative 6 pi rotation. The amount of cycles that you do really doesn't matter. On the other side, what if instead of radius being a positive number, what if we had a negative radius? So let's assume this is x-axis again. Here's the origin. If I say the point radius r and angle theta, this point would be here, r and theta. On the other side, if I say negative r and theta, negative r and theta would be exactly the same length on the other side. So this would be negative r and theta. So what you can see is that basically instead of having this positive r, you would have negative r. So the direction of the angle, instead of being with the x-axis, we change it instead of being in the first quadrant, it would be in the third quadrant for negative r and theta. So what you can say is the angle theta would change to pi plus theta with a positive radius. So you can assume that the radius is still positive. If you have an angle negative r and theta, you can change the radius to be positive. Instead of angle theta here, you'd have theta plus and 180 or theta plus pi. This is another way to look at it. So if you're dealing with negative radius, you can look at it this way. Okay, so here, for example, if they ask you to sketch such a point, let's say negative 1 and pi over 4. This is in polar coordinates, so we want to sketch this in Cartesian system, which means what do I need to do is look at x-axis, y-axis, x, y-axis, but we focus on the radius and angle. So first figure out what is the angle pi over 4. Pi over 4 would be 45 degrees, somewhere along this, and we need to find the radius negative 1. So radius negative 1, if this is radius 1 with the angle pi over 4, then radius negative 1 will be exactly opposite of that, so negative 1 here. So basically at this point, this blue dot is what we're looking for, assuming that this length is 1. Okay, so I can represent this point as 1 and 3 pi over 4, which is pi plus pi over. You can look at it as this point here. Okay, and if you have negative angle, this is something that you should know from trigonometry. So if the direction, this is the x-axis and the direction of theta, say if this is theta, the direction that you look with is starting from the x-axis moving toward the terminal state, and negative theta would be exactly the same thing in the opposite direction. So if this is r and theta, this would be the same radius, and instead of angle theta, you would have angle negative theta. Okay, so if they ask you sketch negative, if they would have asked instead of this point, say sketch 1 and negative pi over 4. 1 and negative pi over 4 would have been radius 1 and negative 45 degree angle. Negative pi over 4. And here is still this length as well. Okay, then you kind of can relate the x and y values. So if I look at the projection of these points, they would have x and y coordinates. We can find out what are those x and y coordinates simply through trigonometry. So here, let's say if we have an angle theta, radius r, and you're looking for the corresponding x value and y value, we should know this by trigonometry, that r times cosine theta. So what is cosine theta? If we look at cosine theta by definition would have been adjacent divided by the hypotenuse, so it would be x divided by r. On the other side, sine theta would be opposite angle, which is y length divided by the hypotenuse. This is exactly the same as the y. So what would be the x value? What would be the y value? You should multiply an r to both sides, so r cosine theta would be corresponding x, and r sine theta would be the corresponding y value. So if we have that, that means if I find out, given the radius and the angle theta, then I should be able to find out what is the x coordinate, what is the y coordinate at this point. On the other side, how can you turn it? This is from x and y to polar. How you can go back from Cartesian to polar would be, how do you given the x and y, how do you find out what is the radius? So if you're given the x and y coordinate here, how do you find this length? Would be basically by squaring the x squared plus y squared. So you're calculating the distance. It would be square root of x squared plus y squared. If you square x and y here, you would get, so what would be x squared plus y squared? It would be r cosine theta squared plus r sine theta squared. That simply would be r squared sine squared plus cosine squared, which is 1. So if I'm looking for, which is 1 times r, which is r squared. So if I'm looking for r would be take a square root from both sides, which you get x squared plus y squared. And theta, what would be this angle? We know that tangent of theta is opposite divided by adjacent, so it would be y divided by x. So what would be theta? Theta would be tangent inverse of y over x. The only thing that you should care about, tangent inverse is kind of bounded by pi and pi half and negative pi half. So when you get the result of tan inverse, you're bounded by these two. So you have to kind of make sure that you consider other cases. Are you in the first quadrant, second quadrant, third or fourth quadrant, based on the given radius and the angle, or based on the x and y value given. Okay, we do an example maybe. So here convert from polar to Cartesian coordinate. So here you're given Rn as 2, theta as pi over 3. So you can think about it as, here we have radius 2 and angle pi over 3. So here's pi over 3 and this length is given 2. We're going to find out what is that point in Cartesian coordinate. So that point would be, what is x, what is y coordinate. X, as we know, it would be r sine theta, and y would be this is sine theta, x is r cosine. So what is the x coordinate? It would be 2 times cosine pi third, which is 2 times cosine pi third is 60 degrees, so 1/2. This is 1, and y would be 2 times sine pi third, which is 2 times square root of 3 over 2, root 3. Okay, so my drawing wasn't that close, maybe something like this. The angle is 60 degrees, so pi third, and here too. So what we found is basically this x coordinate and that y coordinate. How about going backward? Given the x and y, can you go backward and find out what is the polar coordinates? What is the r and theta? So how do we do that? X and y are given. You can always find out those points if it makes it easier to see. So where is 1 and negative 1? Here would be 1 for x, negative 1 for y. So we have this point. You can show the angle in terms of negative, but it's a better idea to use positive angle always. So we want to find out what is that angle, then what is this radius, this theta and the radius. Okay, so what do we know? We can find out first the radius, stays 0, 1. Radius would be square root of x squared plus y squared, the square root of 1 squared plus negative 1 squared. That is square root of 2. Then what is tangent? What is theta? Theta would be tan inverse of y over x, which is negative 1 divided by 1. So this is tan inverse of negative 1. That is negative pi over 4. If you use your calculator, you'll get negative pi over 4. But negative pi over 4 in terms of radian, and we can see that this angle is negative pi over 4. You can write it as negative pi over 4, so you can say, okay, the polar coordinate would be root 2 for r and negative pi over 4 for theta. But you can turn it into positive angle and say root 2, and instead of negative pi over 4, it would be pi over 4. Add 2 pi to it to make it positive. Either one is fine. Okay, just make sure that whatever you get here matches with that point in terms of quadrant. Is it in the fourth quadrant? In this case, yes, they are all in the fourth quadrant. Okay, how about graphing a polar equation? I guess so far what we talked about is only points. So polar equation, meaning you relate radius and theta somehow together. Normally radius is written in terms of function of theta, but not always the case because sometimes it's not easy, so you can assume that there's a function that equation that relates radius and theta. This represents an equation, and here you say r is a function of theta. So for example, if you look at this graph, r equal to 2, you have no information about theta. What does this represent? Radius equal to 2. Which points have radius equal to 2? So length 2, you don't have any information about theta. This point has radius 2. How about this point with the length 2? How about the next one, length 2? So if you don't have any information about the data, basically what you have is given a radius. There's no restriction on the angle. So all these points along the circle with the radius 2 satisfy this. So this r equal to 2 basically represents the equation of a circle with the radius 2. On the other side, what if theta is given fixed and you don't have any information about the radius? There is no restriction. This simply, so let's say given theta equal to 1, by the way, theta equal to 1, this is 1 is in radian, 1 radian. It's not degree, and it's not simply 1 as in our integer 1. This is 1 radian. It's our integer, but it's not something that you can draw it easily. You can draw theta equal to pi over 4 comfortably because you can say this is 45 degrees, but 1, it's like it's close to 30 degrees. So you would have, let's say this is theta equal to 1. So everywhere on this line, whatever point you pick has the angle theta equal to 1. And what about the other side? The other side, maybe the angle is not theta equal to 1 anymore, but you can still consider theta equal to 1 because what you see is this point would have negative radius. This point would have negative radius. So all these points would correspond to the angle theta equal to 1. So this basically represents a line. And here what we had as a circle. What if you have a combination of both? What if you have something like r equals cosine 2 theta, 2 cosine theta? Then can we sketch this graph? So can we graph this function? You can do that in a couple of ways. Maybe first, let's see, draw a table just to make better sense of it. Find out what is r if you're given theta, or find out what is theta if you're given r either. So let's find out what is r if given theta. Theta is given, let's say, 0, pi fourth. You can start with small numbers, pi half. I'm going to be a bit lazy and write 3 pi over 4 pi, and you can continue. So if theta is given 0, what is cosine of 0? Would be, I'm replacing it into this equation. Let me highlight it. So radius would be simply 2 times cosine of 0, which is 1. So you will get radius 2. If you pick pi over 4, cosine of pi over 4 is root 2 over 2. 2 times root 2 over 2 would be simply root 2. If you pick pi half, cosine would be 0. So you get 0. Here you would get negative root 2. And we get negative 2. You can continue do this, but let me just draw part of this graph. You can complete it in a second. Okay, so let's find out where are these points. Angle 0 and radius 2. So radius 2, angle 0. So this is the point where the angle is 0, it's radius 2. Radius root 2 and angle pi over 4. So pi over 4, 90 degrees. Root 2 might be a bit smaller than 2, so here somewhere. This distance is root 2. I'm assuming at 1 and 1. because this is root. And then we have pi half and 0. So at pi half, what we have is 0. Angle pi half, cosine is 0. Then what we have after that is at 3 pi fourth, we have negative root 2. At 3 pi fourth, which is here, you'd have negative root 2. But negative in terms of length would be on the other side, so you would have this point. So let me maybe show the number in terms of 1, 2, 3, 4. These are what we got in order. 1, 2, 3, 4. And the fifth one here, you get the next point, which is at pi, angle pi, we have negative 2. Exactly, come back to this point. So how can you see how this looks like? Because it's not that easy. So you can add a couple more points to kind of see how the structure looks like. But if you create more points, you'll notice that this basically is gonna follow this path. My drawing of the points were not that nice, so you would get something like this. That is the height, and here you would have this circle. Just by going up to pi. If you continue, you will stay on this curve and just going around. So if you pick a couple more points, you will notice. But it's not that easy to just by picking points and seeing where does this end up, where does that end up. So what you can do is basically find out what is the equation in terms of x and y. How can you do that? So let's see how we can do that. So the equation that we have is r equals 2 cosine theta. The center is supposed to be at 1 here. Okay, we want to write in terms of x and y, get rid of r and theta. So we want to find the equation for this curve depending on x and y. What we know is we can get rid of r, we can get rid of theta. But the easier way normally is to make this r squared and this one. So what I can do is, this is a trick, you can multiply. What I can do is I can multiply an r on both sides. Why do I do this? Because left side becomes r squared. Right side becomes 2r cosine theta. Why did I do that? If you remember, we had x squared plus y squared equals r squared, or r equals to square root of that, either way. So r squared would be that. And on the other side, what we have is, what is the x coordinate in polar coordinate system? It is r cosine theta. So now the right hand side simply is r cosine theta. You don't need to do this. You could have said, instead of cosine theta, I replace x divided by r. That is still okay. But then you have to square the left side because r would be square root of x squared plus. You could have said r would be square root of x squared plus y squared. Still the same thing. You could replace those into this equation 1 and simplify. But if you multiply an r, it kind of becomes more clear. What is left side? R squared, which is x squared plus y squared. What do you have on the right side? You have 2r cosine theta. 2 times r cosine theta, simply x. So what do you have as an equation? Is basically x squared minus 2x plus y squared equals 0. And if you add a 1 to both sides of this equation, so I'm adding 1 to both sides. Here, this implies that. This one, if you add 1 to both sides, what you get is x squared minus 2x plus 1 plus y squared equals 1 plus 0, which is simply 1. So I added this one because I could write this now as x minus 1 squared plus y squared equal to 1. And what does this represent? This represents the equation of a circle with the center 1 and 0 and radius here, radius given 1. And you notice this is exactly the circle with the center 1, 0 and radius 1. Okay, so the table is not quite enough because you don't know how to connect these points. Is it the square, is it the circle, is it the ellipse, whatever that is. So normally it's the best choice to find the equation. Based on the equation you can say more about the graph. Here, let's try another one. Sketch this curve. So what we have as a curve is r equals 1 plus sine theta. In this case, maybe not that easy to get rid of r and sine theta. If you multiply an r, you'll still have an r here multiplied by 1, which doesn't really help. So if you have r squared equals r plus sine theta, if you multiply an r, this is what you get. This one is y, that is x squared plus y squared. But this guy is still the square root of x squared plus y squared, so it doesn't really make it that simple. So what we can do is we can try to maybe graph this without the use of x and y. So what do? Let's find out. Normally, the idea would be instead of drawing the table over and over, what you can do is you can relate r and theta based on here. Based on theta, you can relate it to r axis. So what do I mean by this? This means if you pick theta equal to 0, what happens? So this is theta 0, pi half, pi fourth, let's say, pi half, pi 3 pi fourth, pi, and so on. So you kind of have the equation for theta. So instead of doing the table, you can draw it on the x-axis, on the theta and r-axis. So this is basically would be the Cartesian coordinates for theta and r. So here you would have pi over 4, and so on. So let's say 3 pi half and 2 pi somewhere here. Okay, that's 7 pi over 4 here. And I think I made a mistake in the last one, right? 3 pi over 4. I think here earlier I wrote 5 pi over 4. This should have been 7 pi over 4. Because 2 pi minus that would be 7 pi over 4 now that I saw it. Okay, so 7 pi over 4. Okay, so how is the radius related to theta? Think about this. If theta is 0, what do you have for radius? It would be sine of 0, which is 0 plus 1. So r would be simply 1. So I'm going to say radius 1 is here. So I have this point where the radius is 1 and theta is 0. This is corresponding to theta 0. At pi over 4, what happens? Sine of pi over 4 would be root 2 over 2. 1 plus that would be somewhere going up. So let me shift this a bit down because we don't really need to be that. Sorry about that. 1 second, so I can move this. There we go. Okay, so let's say 1 is here at this point. And at pi half, what you have is sine, so you would have some point here. For pi over 4, at pi half, you would have 1. 1 plus 1 would be 2. So you'd get kind of a curve going this way up to pi half, then pi half to pi will grow down, then we'll continue. Let me try to draw this as best as I can. I'll reach 0 at 3 pi half and go up. Okay, so what you notice is basically this is the graph of sine. You would get the graph of sine, just shift it up 1 unit. That's what you should expect. If you had y equals 1 plus sine x, what does it mean? It means You're relating x and y. So this sine x graph shifted up 1 unit. So this is the same. If I assume theta is that axis and radius here along this axis, then basically what do I have is the graph of sine theta plus 1, which is sine shifted up 1 unit. So now I can graph this. I can use that to graph this this curve. How does this curve look like? What happens at theta equal to 0? Radius is 1. So at 0, I have radius 1. This is the first point. What happens at pi over 4? At pi over 4, I kind of have radius. At pi over 4, I have radius root 2 over 2. So it's a bit larger. So here pi over 4 and radius somewhere here. So you have an increasing radius. At pi half, which is 90 degrees, would have a radius 2. So you can expect this curve to go along like that and continue. We draw this. Sorry about the bad graphing. Here, where do we hit? Here would be -1 because it, yeah, so at -1 is where at pi. Here, the radius is exactly 1. So if this is angle pi, what we have as the radius is simply 1. Okay, so this -1 is not really here. This is the length is 1, which is corresponds to the angle pi. Then what happens after that? If you continue, the radius is shrinking. This is the radius will shrink. And at this point, the radius would hit 0. At 3 pi half, radius is 0, which means you have to reach the origin. So the curve will kind of look like this. And then after that, the radius will increase to 1. So we go back to 1. Well, if you draw it, you should expect a symmetry a bit better than how I draw it. Maybe look into the book to have a better understanding of the graph, how it looks like. So basically, you can use this to express how the radius is increasing and decreasing depending on the angle. So from 0 to pi half, the radius is increasing. Then from pi half to pi, still is radius is decreasing symmetrically. These two symmetric, and then after that, radius will decrease to 0. At this point, when we hit 0 radius, you're always at the origin. So if radius equals to 0, you're always at the origin. Doesn't matter where is the angle. So this is for all theta. That means you're at the origin, and after that we go back to the initial point since it's periodic. We'll go back to the same. So sketching this curve may not be that easy, but you can practice and try. How about another one? Maybe this curve. So what we can do is again relate cosine, relate theta and radius. So here's theta. Draw this one a bit better. Radius. Since we may have negative and positive radius, we keep it as this is. So pi over 4, pi half, 3 pi over 4, pi, 5 pi over 4, 3 pi half, 7 pi over 4, and 2 pi. After that, it's just periodic. Okay, so how does this graph look like? What does cosine look like? Cosine would have been starting from 1 and going all the way to -1 and rotating back and forth. But when you multiply the angle, so that's what would have happened if you had cosine would have looked like this, come to pi half and going on. But if when you multiply the angle by 2, basically you divide this, you shrink the curve along the x-axis, so it looks like this. Pi, you would hit back at 1. So if you remember, the period of the graph will divide by 2. So instead of 2 pi, you would have period of pi. And if you go back to 2 pi, you'll get the same graph over and over. And so this is basically cosine 2 theta. This is the same as this graph. But we want to draw it in the x and y coordinate system. So how do we do that? Draw it here. Okay. So how can we draw it? We can start from the first point. Where is it? Here. Angle 0, radius 1. So angle 0, you mean you're on the x-axis, radius 1. So this is radius 1, xy. Next point that makes sense is this point. Where is that point? Has radius 0. So somehow we have to end up in the origin. But what happens to the curve is, as the angle increases, the radius is decreasing. So kind of you would have such a shape. As the angle increases, the radius is decreasing. Maybe not symmetrically, maybe somehow look like this. And this happens as the angle is getting closer and closer to 45 degrees. This is where the angle is pi over 4. We hit 0 in terms of radius. At this point, this is where the radius is 0. Then the curve will have a negative radius after that, and up to pi half. At pi half, which is at 90 degree, so at 90 degree, we would have radius negative 1. So this is pi half and radius 1. Radius negative 1 would be on the other side. So somehow we reach this point, negative. And how do we reach that? As the angle is increasing, the radius is also increasing in terms of negative, which means as we increase the angle, so it should look like this. As we increase the angle, the curve will, the radius will increase positively if you think about it. But on this side, since it's negative, that means exactly opposite of that on the other side. It means you will have this curve. Radius is negative, so it will be on the other side. So you have this curve. Let me try to make it a bit better in terms of drawing. You reach this point, then it will continue. This was this up to 3 pi over 4. The 3 pi over 4 we hit 0 again. So at 3 pi over 4, which means let's continue in that. At 3 pi over 4, this is 3 pi over 4. This would be 3 pi over 4 as an angle. So we should hit 0 again, so we should come back to the origin. So how do we do that? Continuing from this point. Since the radius is still negative, you should say, okay, this is how it looks like. You would have this curve and look like this. Just because the radius is negative, instead of being here, it should be exactly on the other side. So it should be right here. So you can change the angles instead of looking at the negative radius. That's why originally I started with get rid of the negative radius and think about it as positive angle, as positive radius, and change the angle. Instead of being 3 pi over 4, you should change the angle by adding pi to it. So it will be at 7 pi over 4. So it's 7 pi over 4 of angle, which means along this direction. Here you would have the radius of 1 decreasing towards you. And if you continue this process, you notice that next step would be going along this curve, hitting 0, hitting 1, and then continue. It looks like something like this. This is like a flower with 4 pieces. 4 equal pieces. Okay, so the steps that we followed is this is starting from here, going along this curve. There's maybe 1, 2, 3, then you go to 4, 5, 6, 7, 8 pieces. And those are exactly correspond to these pieces. First, second, third, fourth, fifth, sixth, seventh, and eighth pieces of this flower. So try to go through by picking more points. Maybe it gives you a clearer idea of how it looks like. Okay, now we can talk about symmetry. What is symmetry? Symmetry is something that I already mentioned, that if you're given a radius and an angle, can you tell me what is this point relation with that radius and angle? If you remember, this point is basically r and angle theta. Here will be correspond to that. You can find out the coordinate of this point would be exactly the same radius, but the angle will be negative. So if you have an r and theta, on the other side would be r negative theta. So if you have a symmetric about the theta of 0, or you can think about it as about the x-axis, or the about the x-axis, then you can say, okay, they call it polar axis. So if you have symmetry about the polar axis, basically theta has changed to negative theta. The curve will be symmetric about that. Every point on the other side, you would have another point. That's how you deal with the symmetry. What if we change radius to negative radius? That means you would have this point r and theta will be correspond to negative r and theta on the other side, exact of the origin. Because negative radius would be the same angle, just opposite direction. Okay, so same angle, but instead of being in the positive radius, you'll have negative radius. And so if you change the radius to negative r, and the curve stays the same, if the equation stays the same, for example, here we have r squared equals 2 theta. If I change the radius to negative r and I square it, still, what do I have after simplification is that these two represents the same equation. This is the same as that. So what can I say is r and negative r both belong to that curve. So these 2 points both belong to the curve. So I can say the curve structure is similar to this. The point r theta, if it's on the curve, then negative r theta would be exactly on the curve. And in this case, what I can say is you would have something like r equals theta squared, or cosine theta. Because cosine of theta and cosine of negative theta, they're the same. So these two satisfy the same equation. So I have a symmetric graph about the polar axis. Okay, because these two, again, these two are the same. Cosine theta and cosine negative theta. And in some cases, you can look at the symmetry about the 90-degree angle, or the pi half, the vertical line. And here, assuming this is radius, you can still say this is the same radius. And the angle, what happens to the angle, instead of being theta, what you have as the angle here is would be pi minus theta, 100 minus theta. So these 2 points are correspond to each other. This is kind of when you're dealing with something like r equals cosine square theta. Because cosine theta and cosine pi minus theta, they're opposite. When you square it, then you'll get the same thing. So this doesn't happen that often, but if it happens, it will have the fact that instead of theta, if you replace pi minus theta, you should still get the same curve. Okay. Okay, so this is about the symmetry. Finally, we can talk about the tangent. All these was just preparation so we can talk about the tangent for polar curves. Well, because we want to introduce the derivatives for polar coordinates. So this is an important topic. Tangent to polar curve. It's very easy because we already have talked about the uh, what the intermediate variable or parametric equations. So if you can say I have an relation between r and theta, let's say r is given as a function of theta, then what we know is y is equal to r sine theta, x is given r cosine theta, this is polar coordinate. Then instead of r, you can think about it as f of theta sine theta, which basically what do I have is y as a function of theta, which is f of theta sine theta. And similarly, what you have as x is a function of theta times cosine theta, which is still, this is some function of theta, and here you have another function of theta. So we relate y and x based on a third variable, which is parametrically. And now we can discuss what is dy over dx. What is the derivative? Which in our notation it should be dy divided by d theta divided by dx divided by d theta, based on the parametric equation that we learned. So if we're looking for dy over d theta, dy over dx, it should be dy over d theta divided by dx over d theta. But just then apply the derivative to this term. Use the product rule, derivative of f prime, derivative of f times sine theta plus f times derivative of sine. Derivative of f, since f is just simply r, we assume that f is the same as r, so you can say derivative of r with respect to theta multiplied by sine plus r times derivative of sine theta. R is the same as the f function. And here the same, you can say it for the denominator. One thing that you should be aware of is if dy over dx is undefined, if this is undefined, it means this denominator is 0, which means you have this equation equal to 0, which means you have a vertical asymptote or vertical tangent line. Okay, so in those cases, you gotta be kind of careful. If they ask you for vertical line, you should set the denominator equal to 0, find out for what theta and r you'd have vertical tangent line. So here's an example. Let's say find the slope of tangent line at theta equal to pi over 3 or r equal to 1 plus 2 cosine theta. So what they were looking for is dy over dx evaluated at pi sine. This is our question. So first we need to find out what is dy over dx, which would be, you don't need to memorize dy over d theta divided by dx over d theta. What is y? Y is r cosine theta, sine theta, and denominator is x is r cosine theta. But now r is given already as a function of theta. So instead of that, I can write what I am looking for is basically the derivative with respect to theta of 1 plus 2 cosine theta times sine theta. This is r times sine. And similarly, the derivative of that with respect to 1 plus 2 cosine theta times cosine theta. So this is basically what you're looking for. So take the derivative of each one separately. You don't need to apply quotient rule. Derivative of the numerator, in this case, divided by the derivative of the denominator. That's what we're looking for. So d over d theta of 1 plus 2 cosine theta times sine theta. You can apply the product rule, or you can just simply distribute and say I'm looking for sine theta plus 2 sine theta cosine theta derivative. And this is simply cosine 2 theta. So you have sine theta plus cosine 2 theta derivative. You don't need to change it to this, you can apply product rule, but this is easier. So derivative of sine would be cosine theta, derivative of cosine 2 theta would be minus 2 sine theta, 2 theta. So this is the numerator derivative. Similarly, derivative of the denominator, d over d theta of 1 plus 2 cosine theta times cosine theta would be cosine theta plus 2 cosine squared theta derivative. Derivative of cosine, negative sine theta, plus derivative of 2 cosine squared is 4 minus 4 sine theta cosine theta, which is the same as negative sine theta minus 2 sine 2 theta. You can write this as 2 sine 2 theta. So we found out derivative for both numerator and denominator. This is the denominator derivative. So now, what is dy over dx? Evaluate the power of 3. It will be evaluate cosine theta minus 2 sine 2 theta divided by negative sine theta minus 2 sine 2 theta. Evaluated the power of 3. Cosine of power of 3, that is 1/2 minus 2 sine of sine at 60 degree would have been root 3 over 2 at 2 and what 20 sine at 120 is still root 3 over 2, and here you would have negative root 3 over 2 minus 2 times again root 3 over 2. You can simplify by multiplying at 2 everywhere if you want. These two can cancel out, these two can cancel out, and you would have 1 minus 2 root 3 divided by negative root 3 minus 2. That is the slope of the tangent line at the point of power. Okay, every other example is very similar. At the moment, we just want to focus on the first derivative, be able to find out what is dy over dx. As we go on, we will build on this. So try to do more examples to find out if you can calculate the derivative. Or for example here, try to find out where is the derivative equal to 0. So as you found the derivative says equal to 0, find out where the numerator would be 0. Or similarly, where the tangent line is vertical by setting the denominator equal to 0. Okay, so practice on those. I'm going to stop at this point.